All right, y'all. So tonight we're going to go over section 2.4. And section 2.4 is the algebra of functions. And there's mainly the four operations we'll look at on these. It's going to be adding, subtracting, multiplying, and dividing. So here's sort of the definition of the symbolism you'll see. So given two functions, f of x and g of x. First operation we'll look at is f plus g of x. So when you see f plus g of x, they want us to take our f of x function and add to the g of x function. Now we'll say this, when we're adding, what you do on adding is we're going to drop parentheses. And then add like terms. And really, that's all we're going to do when we're adding the functions, okay? 2 will be f minus g of x. So that'll equal our f function minus the g function. Now, if they do g minus f of x, then I would reverse the order. But the trick on subtraction, when you drop the parentheses, you're going to distribute the subtraction to get rid of the parentheses. Once we get rid of the parentheses by distributing our subtraction, we then add like terms. Okay, and really the only difference between adding and subtracting is that on subtracting, we definitely got to distribute through the parentheses that follow the subtraction. So our next operation is going to be multiplication. So f times g of x equals f of x times g of x. All right, so since you're going to be multiplying, the trick is you're going to use the distributive property or FOIL. We'll use the distributive property or FOIL to get rid of their parentheses and then add like terms. So if you notice all three of these, to simplify them, we add like terms once we got rid of them parentheses, okay? Fourth is finally division. So f divided by g of x is going to equal your f of x divided by g of x. So let me ask you a question. Since I'm dividing this g of x down here, what can the g of x not equal?
0.
And there you go. G of x cannot equal 0. And they're not really going to, at this time, they're not really going to make us simplify expressions that are being divided. That'll be later on in life. But they will give me numbers to put in for the x and evaluate that, okay? So that's going to be our 4 operations. And remember, we're going to deal with domains, so remember this on number 4. Since it is fractions, that may not equal 0, okay? What we're going to do, I'm going to work some examples. I'm going to give us 2 functions, and then we're either going to add, subtract, multiply, or divide, okay? So the first one we're given f of x equals x squared plus 2. G of x is going to equal x plus 3. They want me to find f plus g of x. So they're not giving me any values to put in for the x. They just want me to take these 2 functions and find out what I get when I add them. So I'm going to come down here, f plus g of x. Now, usually when I'm dealing with functions, my first step, I start out by putting my functions in parentheses. Let me let one in real quick. Okay, so start out by putting your functions in parentheses. So my f of x would be the x squared plus 2. And y'all, I'm following this pattern up here that tells me when I got f plus g of x, it's going to be the f of x plus the g of x. All right, my g of x will be x plus 3. So remember up here, when we're adding, it said we just drop the parentheses and then add like terms. So we can drop our parentheses without changing any signs. So I got an x squared plus 2. Then I'll bring out my plus x plus my 3. All right, so y'all on this one, can I go further?
Yes. 2 plus 3 is 5.
Yes.
Yeah, there you go. So y'all do have them like terms right there. So we'll add those and be done. So I'm going to put mine in order again. So I'm going to put my x squared first. Plus my x. And then what y'all said was what? Add the 2 and the 3. And make that a 5. All right, so no more like terms, y'all. So right there, final answer. So these aren't too bad. It's just looking at what operation they're giving you. And then trying to simplify it. So let's do some multiplication. So on this one, we're going to be given f of x equals x squared minus 4. My g of x will equal x minus 2. They want us to find the product f times g of x. Now we'll say this, sometimes they'll use the little dot for multiplying. Sometimes they'll just put the f and g by each other for multiplying, okay? All right, so that's what we're going to find. F times g of x will equal my f of x times my g of x. So when you're multiplying functions, then parentheses will be right next to each other. Come in and put your f, which is x squared minus 4, and my g, which was x minus 2. So guess what, y'all? We got 2 things times 2 things being multiplied. So this is where we're going to technically do our FOILing. So let me ask y'all this. What do I get when I multiply this x squared times this x?
It's gonna be x to the third.
X to the third. Good job. And remember, treat the x over here like it's got a 1 and just add the exponents. Good job. X squared minus 2.
Negative 2x squared.
There you go. Then we got the negative 4 times x. And then the trick on these is keep it up with signs. So now I got a -4 times that -2 +8. So y'all, can I add any like terms on this one?
No.
No, because everything is different, so good job. So that there would be our final answer. And so let me let y'all write that real quick. But you gotta admit, this is a lot funner than trying to graph in math lab, okay? All right, so I'm gonna throw y'all a little bit of a curveball here. Just to see what we do to this. I'm given f of x equals x² - 3. My g of x equals x - 1. They want us to find g times g of x. So we're finding g times g of x. So let me write that down. So since I'm multiplying, my parentheses will be right next to each other. So y'all looking at this problem, what would you put in the first parenthesis?
X - 1.
Oh, there you go. And how about the second parenthesis?
X - 1.
X - 1. So this is almost like doing an x - 1 squared since it's the same function being multiplied. Good job. So they threw us the curveball. We didn't even need this f of x stuff. They just stowed it in there to try to mess y'all up, okay? So 2 things times 2 things. Once again, I get to FOIL. All right, y'all. So x times x gives me an x². X times -1 over here gives me a -1x. Distributing the -1, -1 times that x gives me a -1x again. And y'all finally the -1 times the -1 gives me a +1. Are y'all going further?
Yes.
Good.
Add like
Ne-
terms.
-2x.
Okay, so there you go. So I get an x² - 2x plus my 1. Good job, y'all. So just watch out for what they're putting up in here when they want you to find it, okay? So let me throw some numbers in for my variable. On this one, I'm going to be given f of x. Yo, that's going to equal -18x plus 8. G of x is going to equal x² plus 5. So this one, they want me to find f of 2 plus g of 2. Now, I'll tell you the truth on this. Since the since the numbers going into each one of these is the same, this could be actually written f plus g of a 2. So anytime they match, you could technically write it like that because you're putting the same number in for everything. So let's see, I'll just write it down here like they got. So f of 2 plus g of 2 will equal my f function plus my g function. But y'all, I probably won't put this -18x plus 8 down here. I'm going to put something else in there. So let me start out. I'm going to put the -18, then some parentheses, and then I'll put my +8. So what am I putting right here in these parentheses?
2.
I'm gonna put that 2. But that's what the F of 2 is saying, hey. Put this 2 in for your variable. And over here, you got an x squared, so that's gonna be what, a 2 squared plus 5. So order of operations inside of each parenthesis. Once I get a final answer out of each parenthesis, I will add last. So in here, you got multiplying and adding. This one, you got exponents and adding. So multiplying takes priority over adding first. So my negative 18 times 2 would give me what, a negative 36, and then bring down your plus 8. Over here, you're going to do the exponent first. So 2 times 2 would give you a 4, and then bring down your 5. So now, y'all, that I got one operation left inside of each parenthesis, I'm going to get a single number. I can actually drop those parentheses. So let's see, this is what, negative 36 and 8 should be what, a negative 36 minus 8 is what, 28? Plus, my 4 plus 5 is a 9. All right, so we locked everything out except this last step of adding. Negative 28 plus a 9 is a negative 19. So if they give us numbers, we put those numbers in for those variables and then play with it, doing our order of operations.
Okay, can I go back up?
Mhm.
Like I get it, but I just want to make sure. So when we see it, so I know what I'm looking for. So hold on. It's where we did the where we're adding the 2. The third step.
Oh, right here?
Yes. So the f of x, so that the in parentheses, negative 18 to the second plus 8.
Well, that's times that too. See up here, you get your negative 18 times the x plus 8.
Okay. Okay.
So when I put it down here in parentheses, all I did was replace that x with that 2 they gave me.
Okay. And we still use the same formula. We're just adding the 2 in
Right.
between.
It's going to be the
because
same
they're
thing. So your
Okay.
first step, technically, you could have put negative 18x plus 8 here and x squared plus 5, but then you would have had to replace those x's with that 2 they gave us, okay?
Okay. I just want to make sure I'm writing it right.
Mhm.
Because I know if I write it wrong, then the whole thing.
Mhm.
Okay. And then we do the same. No, we didn't do the same on the other side.
Well, on the other side, that was my g of x. So I brought
It's
down,
right.
I brought
And
down
it
my
didn't
x.
ask okay.
Mhm. And since these both had the same numbers right here going in for the x's, you just had a bunch of 2's being replaced for all those, okay?
Okay. Okay.
All right,
Thank you.
let's see, this one, let's see. So they're giving us f of x on this one equals negative 11x plus 6. G of x is x squared plus 14. They want us to find f of negative 5 divided by g of a negative 5. So this one is division, so they will give you division with replacement values, okay? So y'all, here we go. F of negative 5 divided by g of negative 5 is going to equal my f function on top divided by my g function on the bottom. So f on top was a negative 11x plus 6. So we're going to take the negative 11, the plus 6, and I'm going to replace that x with a, what y'all think?
-5.
There you go. On the bottom was the x squared plus 14. So I'm gonna put in my -5, square it, and add 14. Now listen, the reason I'm putting parentheses around the numerator and denominator is if you do this on the calculator, you gotta have parentheses to separate the numerator from that denominator. I use extra parentheses around the -5 here, because when you square anything, that negative times negative will become a positive. So you gotta put negative numbers inside of parentheses when they got an exponent following them, okay? All right, so this is pretty much exactly how I put it in my calculator. Now, on top,
Can you show us that?
so let me see. Let me pull my calculator up real quick on my screen. And I'll show you 2 ways you can put that thing in there. How about that? One way with parentheses, and then the other way, you don't necessarily need them. All right, y'all, so let me share my screen through the calculator. So if I was going to put this in, first thing I would hit would be my parentheses for my numerator. And then I would come down here and get the negative key on the bottom. Put in my 11. And then I'm going to use parentheses to multiply that -11 times the -5. All right, then I had plus a 6. So that was my numerator. So now I'm going to close parentheses on the numerator. And I'm going to hit the division key. And I'm going to open up parentheses for my denominator. Now my denominator was -5 squared. So since you're doing a -5, you need to put it in parentheses. So -5. Close the parentheses and square that. All right, then I need to arrow down. And then it was plus 14. So let me come over here and get my plus 14. And then I'm going to close those parentheses. Whoops, let me go back. I think I got too many 4s in there. So I'm going to delete one of those 4s. All righty, so if you're doing it straight line, that's how I would put it in. I'm going to hit enter. Now remember, we don't want a decimal answer. We want a fraction answer. So when you get a decimal answer, you're going to come over here and hit math. Number 1 is turn your answer into a fraction. So hit enter twice. And I get, oh, what is that? 61 over 39. So let me show you the other way. Remember, I showed you that you could get fractions if you hit the green alpha button and the y equals. The first option, n over d, if you hit enter on that, that gives you a fraction on the screen. So if you do it that way, you can come in and go -11. Whoops. So -11.
You don't have to put the parentheses?
No, if you do it where it already knows it's a fraction.
Okay.
See, if you do it straight line, it don't really know where your fraction's going to be. But this way, it tells me what my numerator and denominator is. So then you would come in and what? Put your -5. And then plus 6. So if I use that alpha key, the alpha y equals, it knows the top and bottom of my fractions because I'm sort of putting them in there. So let's do our -5. Now the -5 still has to be in parentheses though when you square it, okay? And then arrow over and put what? Plus 14. Whoops. Okay, I'm gonna have to restart it. So y'all see what I was doing though, right? Because I think I hit a wrong key and I
Right,
did.
I got the same answer. You didn't
Yeah.
add the 14.
But here's the trick. When you do the alpha y equals, it gives you, since you're starting out like a fraction, it's going to give you fraction answers over here, okay?
Right.
Yeah, I would have to go back up and edit that. I don't think it's going to let me. Oh, it might. Let me see. Okay, it would let me. So then I would come in and put in my plus 14.
What did you hit?
What now?
What did you hit?
To get back to my problem?
Yeah, I see you arrow up.
I arrowed up. See how it's highlighting the answer over here now?
Yeah.
You're gonna arrow up one more. It gave me the, see this problem I messed up, so I wanted to finish it off. So
Mhm.
I highlight it and I hit enter, and it brings that problem back to the screen.
Oh, okay.
Pretty cool, ain't it?
Yes.
So now I got the right problem in here. Watch, it'll give me whatever we're supposed to get. What, 61 over 39. But it don't have to be switched back like my decimal did. So y'all, I guess we know what we better get when I do this by hand. Looks like we better get what, a 60 something over 30 something. So here we go. Negative 11 times negative 5 gave you a 55 plus 6 on top. Negative 5 squared is 25. So that gives you 25 plus 14. So they added the top. That gave me my 61. And then the 25 and 14 gave me my 39. And we know that's not reducing because it didn't reduce it while ago when we did it on the calculator. So final answer. So yeah, that's both ways that you can put these into the calculator so that you don't have to worry about parentheses as much doing it the second way, okay? All right, oh, time for some subtraction. So y'all, f of x is going to equal 3x minus 6. G of x is going to equal 9x minus 2. They want me to find f minus g of an x. So they sort of skip back and forth, putting x's here and putting numbers. So this one, they didn't give me no numbers. So I'm just going to go f minus g of x will equal my f minus my g function. So f, we don't have no replacements, so we'll bring down that 3x minus 6. And then g will bring down our 9x minus 2. So for this problem, this next step is the most important part when you drop parentheses. So do y'all want to guess what I'm about to write down here?
It's gonna be changing the 9x to a negative 9x and the negative 2 to a positive 2.
Man, but all we got to do is what? Distribute that negative. There you go. So the first part's going to say what? 3x minus 6. And then you said a negative 9x and what, a positive 2. So at this point, can y'all go further?
Yes, negative 6x minus 4.
Okay, so good job. 3x and negative 9x were like terms, and you got me a negative 6x. And then you said, well, that negative 6 and that positive 2 were like terms and got me a negative 4. Good job. So really, these aren't bad if you understand what they're asking for on these, okay? It's just a matter of trying to get rid of parentheses and then add like terms. All right, so I'm gonna give y'all a curveball here. I'm gonna do an f of x again. F of x will equal negative 2x plus 3. G of X is going to equal X squared minus 4. We're going to find G minus F of X. All right, so I'm going to write that right here. G minus F of X equal my function minus my function. So what would y'all put in the first parenthesis?
X squared
Squared
minus
minus 4.
Oh, I think y'all said it. Say that one more time.
X squared minus 4.
And then over here, I guess would be my what, negative 2x plus 3. Good job. So y'all watch them. They're going to try to reverse order on you sometimes, okay? All right, so y'all want to get me this line?
It will be x squared minus 4 plus 2x minus 3.
So it sounds like you're getting that distributor property down pretty good. There you go. Can I go further on this one?
Yes.
Because we got these what numbers sitting here. So I would probably put my x squared first. Then I got what, a 2x. And then that's what, a minus what, 4 and 3, give me minus 7 there. All right, question on that one. So I'm gonna do a couple more of these and then we'll get into our domain stuff. So this one has f of x equals x squared minus 12. G of x equals 11 minus x. They want us to find f times g of an n. You know, f times g of n will equal one function times the other function. All right, so let me pull my chat up. I see a chat. Oh, you keep getting, yeah, if you get kicked off, I'll keep trying to get y'all back in here, okay? Because it usually pops up when y'all are trying to get back in. All righty, question of the day. What's going in the first parenthesis?
X squared minus 12.
Oh man, y'all rolling n squared minus 12. Because they want me to put an n in for all the x's on this one, okay? Which means over here, since I had 11 minus x, I'll replace that x with the n also, and that'll be 11 minus n. So they're just being fancy now. They said, well, we gave them numbers a while ago. Let's just throw a variable here and see what they do. And y'all guess what? 2 things times 2. We get to FOIL. So we're going to take our n squared times 11. That'll be 11 n squared. N squared times a negative n. Now keep up with these signs. So a positive and a negative will make that negative. And then the n squared times the n would be what, an n to the third. All right, y'all. Now I'm going to distribute negative 12. Negative 12 times 11, that's going to be a negative 12 and 11.
132.
132. And then you got what, your negative 12 times a negative n. So that'll be a positive 12n. So can you go further? So
No,
what's
but you can I guess you can move around the negative n cubed and the
yeah,
11.
it's the only thing I can do. There's no like terms, but if I want it to be in descending order, exactly, put your negative n3 plus your 11n squared. Oh, then I had what, a 12n, and then minus my 132. So that's really all you can do is just put it in descending order. I don't think they make you do that in the beginning, but they might, okay? All right, so like we said, watch for what they're giving us for these replacement values. So one more of these, and I'm gonna do another division. And then I'll play with y'all on some domain questions. All right, so f of x equals x squared minus 17. G of x equals 13 minus x. On this one, they want us to find f divided by g of negative 6. All right, so f divided by g of a negative 6. So I'm going to get a fraction again. So I got my top divided by my bottom. Remember, they're giving me a value here, so I'm going to put my negative 6 in for that x, which means I'm going to put it in its own parentheses and square it, and then subtract that 17. Then here I got 13 minus a negative 6. So 13 minus a negative 6. And I'm really just putting this negative 6 in parentheses to separate them two subtractions. Calculator wouldn't necessarily have to have these bottom parentheses around the negative 6 because it knows when you subtract a negative what to do. So y'all starting on top, I'm squaring a negative 6, so that's going to give me a 36 minus 17. Down here, all I'm going to do, I got 13 minus negative 6. I'm just going to make that 13 plus 6. So remember, when you subtract a negative, it makes it a positive. Oh, let's see what we're going to get on that. 36 minus 17.
Negative 9. I mean, positive 19. I'm sorry.
Oh, there you go, positive 19. And then on bottom, you got what, a 13 plus 6.
19. So it'll be 1.
So it's going to definitely reduce to a 1. So those aren't too bad. Just keep up with the order of operations when you're playing with these, okay? And functions are designed pretty much where you got to work inside those parentheses before you can come out and do that main operation on those, okay? So let's see if y'all remember anything about my domains from Monday. I'm given two functions. F of x equals x squared. I'm given g of x equals 4x minus 7. I'm going to find the domain of the sum, difference, and product of f and g. So basically 3 problems here. They want me to find a domain when I add them, find a domain when we're subtracting them, and find a domain when we doing a product. So let's do our sum first. The sum would be f plus g of x. That's going to equal our f equation plus our g equation. So f was an x squared. G was the 4x minus 7. Now we don't even have to really simplify this any further? Because all we're looking at is our domain. So let me ask you all this. Are there any numbers that I need to kick out of my domain? So let me ask y'all this. Do y'all remember the only thing in my domain that I was worried about Monday was fractions? So do y'all see any fractions? So there's no fractions on this, y'all. So that means our domain, if there's no fractions, our domain was what?
All real numbers?
All real numbers. So X such that X is a real number. Remember, because the only thing I'm worried about is the bottom of a fraction being 0, which makes it undefined. If I don't have no fractions, then that means really I don't have any values to exclude, okay? So do this, f minus g of x will equal our f, which is x squared, minus our g, which is 4x minus 7. Any guesses on that domain? So let me ask you all this. Would we have to exclude any numbers for these x's?
No.
No, because you still have no fractions, right? And anytime there's no fractions, we know this is going to be all real numbers. All right, so what's next? The product. The product would be f times g of x. So that'll equal my f, which is x squared, times my 4x minus 7. So y'all should be able to get me this one now. What is my domain? Oh, y'all, let me stump you.
It's all real numbers.
It's all real numbers. Because once again, I'm just multiplying, so I don't have to worry about fractions when I multiply. So if I multiplied all that, I'd still never get a fraction. So x such that x is a real number. And I'm going to tell you the truth. Usually the domain for all three of these is always going to be the same, given what your functions are, okay? All right, so all right, let me turn the page and we'll try this one. So doing the same things here. So this one we're given f of x equals 1 divided by x minus 3. G of x equals 9x to the third. So once again, find the domain of the sum, difference, and product of f and g. Now, that one that I just did a while ago, if I'd have had division as one of my operations, it would have had some numbers you would have had to exclude. But they didn't ask me for division. What they're wanting y'all to realize is that the sum, difference, and product are pretty much all the same, okay? All right, y'all, so let's start by adding. That'll be f plus g of x. That's going to equal our f, which is 1 divided by x minus 3, plus our g, which is 9x to the third. So, are we worried about any numbers on this domain?
Yes, it's gonna be you'll have to solve the equation for x minus 3, and then it's gonna be x minus 3 equals 0. You add 3 on both sides, and it's gonna give you a positive 3. And then it's, I think the answer is x such that x is a real number and x will not equal to 3.
Man, that's perfect. 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 She seen we had a fraction. And remember, the fraction on the denominator can't equal 0, like she said. So set x minus 3 equal to 0. Girl, you did that really perfect. All right, then she said over here, she said, well, since I got a 3 there, I got to exclude 3 from this domain. So she came in and said x such that x is a real number. And x cannot equal that 3. Good job. Okay, so those are tricky at first, but I think you are starting to get the hang of these. All right, so how about this one? I got subtraction. 1 over x minus 3 minus 9x to the third. What y'all think that domain will be?
Okay, I'm sorry. It's gonna be x such as, such that x is a real number, and x cannot equal to 3.
So once again, it looks like adding, subtracting, and multiplying are all going to have the same domain again, right?
Yes, sure.
So this one too?
Yes.
Yeah, because I'm putting 3 there. That's going to make that undefined. So kick that out once again. And that's why we do these kind of examples, is so that y'all see that these 3 operations usually always, well, pretty much 100% will have the same domains. Where I'm at is a real number. And x cannot equal 3. Okay, so one where there weren't no fractions, all 3 of these operations had the same domain. If they have fractions, all 3 of these operations still have the same domain down through here, okay? So if you're doing these 2 problems and you get that first domain, you're pretty good on the other 2, okay? So I will actually now do one with division. We'll find the domain of something being divided. So f of x for this one will be 4x minus 5. G of x will be 5x minus 35. I'm going to determine the domain of f divided by g. So we'll set that up. F divided by g of x will equal my f equation on top, which is 4x minus 5, divided by my g on the bottom, which is 5x minus 35. So you definitely have a fraction. So the first step you would do would be what? To set that denominator, 5x minus 35, equal to 0. All right, so y'all, what I'm going to do, add my 35. Once I move that over, then I'm going to divide by the 5. All right, let's come in and divide by the 5. So that gives me what X is looks like a +7. So 7 times 5 is 35. 35 minus 35 makes that a 0, which is undefined. So we're only kicking that out. So you're going to have X such that X is a real number. And X cannot equal 7. So let me do one more for y'all to play with. You're going to have f of x equals 3x plus 2. You're going to have g of x equals, oh, let me see what I want here. How about a 7x plus 28. So y'all, I'm gonna let y'all do this one. I want y'all to determine the domain of f divided by g. So I'll give y'all a few minutes to play with that and see what y'all get. And mainly, I'm just worried about if there's any numbers y'all might exclude, okay?
We would exclude 4 or a -4.
-4, perfect. Because -4 makes that what, a -28, and that -28 plus 28 would make that a 0. So good job. All right, so there's my fraction. Set that denominator equal to 0. And it was that having to subtract that 28 is what made this answer negative, okay? Because then you got what, 7x equals -28. Divide them by the 7. So there you go. X is a -4. So let's kick out the -4. Okay, so those are examples of division. So division, if you got a variable in that denominator, there's got to be some number you're going to kick out every time, okay? All right, let me see. Yeah, y'all, that is all of 2.4. So let me stop my share. So do y'all have any questions on what we did tonight? I sort of keep this first week or two sort of mellow so that y'all can get back into the flow of everything. So for this week, that would technically be due by Sunday, but I won't see y'all again until what, Wednesday? So you really have that extra time to work all the way through 2.4. And then once we come back, Wednesday, we got 2 semi-short lectures over 9.1 and 9.2. And then the next week will be the last week of material for test 1. And that covers 3.5 and 3.6, I think. All right, y'all. So what kind of questions y'all got?
I don't have any as of now.
Okay. So someone asked me in the beginning something about graphing. If you're having if you're graphing those first few sections, 2.1 and 2.2, and you get a graph that is really similar to what they're giving you for the answers, but they're marking it wrong because you might have been a point or two off, email me and I will give y'all credit for those, okay?
Okay, because that was definitely something that I was having an issue with the last one, so I
Yeah,
appreciate that.
if you do, so in two.
Yes, me too.
Yeah, because there's no graphing in 2.3 and 2.4, so definitely if you get that, email me. And I'll look at that real quick and give you points on it. I can override them.
Okay,
Um,
I took pictures of it.
right. So Natasha asked me, how soon can I get an update on the calculator? So you're talking about my programs? Oh, let's see, Natasha Gibbons, you hear me? I don't know if she might be having audio. So Latarsha, let's see. I guess she got kicked off. Okay, but come up to the campus on the office hours and or set up an appointment with me, and I'll, when I'm on campus on Monday or Wednesday or Friday, bring your calculator and I'll update it for you, okay? And that can be as soon as you want.
That's just gonna ask, how soon do we need to start doing that? Because I have the other calculator to the 83.
Uh-huh.
Okay.
Yeah, so y'all still have a few weeks before it'll be after test 1 when we actually start getting into that quadratic formula.
Okay.
So I would say probably 2 weeks from now, you'll at least want to get up there so I can get them programs in, okay?
Okay.
All righty, so yeah, Patrick, y'all send me those problems and I'll override those, all right?
Solid. Thanks, man.
Okay. All right, now I'm trying to see my chat, so I don't see any more questions, so I'm gonna end our recording and I'll send this out later tonight for y'all.